There is a graveyard on Mars. No gravestones, no flowers, no visitors. Only the rust-colored silence of a planet that has been dead for billions of years. Somewhere on its surface sits a machine the size of a golf cart, buried up to its wheels in soil it never managed to escape from. It has been there for more than 15 years. It will remain there for millions more. But before it stopped moving, it changed everything we thought we knew about the red planet. Today, we are telling the complete story of the Spirit Rover, a machine sent on a mission designed to last 90 sols, or Martian days, that somehow survived for more than 2,000. A machine that stumbled into discoveries by accident, dragged a broken wheel across an alien world, and still managed to rewrite the history of Mars. This is a story about failure, endurance, and what happens when a robot refuses to give up. Let's go back to the beginning. It is January 2004. Spirit has just survived one of the most violent landings in the history of planetary exploration. After a 7-month journey through interplanetary space, the spacecraft carrying Spirit slammed into the Martian atmosphere at more than 19,500 kilometers per hour. It had no engines to slow itself down. Instead, it relied on a heat shield, a parachute, and an extraordinary system of airbags that inflated around the lander during the final seconds, turning it into a bouncing, tumbling sphere of foam and metal. Spirit struck the ground, bounced dozens of meters back into the air, slammed into the surface again and again, rolling for nearly a kilometer before finally coming to rest inside Gusev Crater, a 166-kilometer-wide basin scientists believed may once have been filled with water. The mission had one focused objective: find geological evidence that water once existed on Mars. Because if water once existed there, then Mars was not always the frozen desert we see today. And if it was not always a frozen desert, then at some point in its ancient history, it may have been capable of supporting life. No pressure. Spirit's scientific instruments were designed specifically for that search. Its rock abrasion tool, known as the Rat, could grind away the outer layer of rocks, exposing fresh material untouched by the Martian atmosphere. A microscopic imager captured close-up photographs of textures and grain structures. An alpha particle X-ray spectrometer measured elemental composition, while a Musbauer spectrometer identified specific iron-bearing minerals. And of course, Spirit carried a full camera system that allowed it to navigate, study, and photograph its surroundings in extraordinary detail. It was an impressive payload, but within days of landing, it almost became irrelevant. On Sol 18, Spirit went silent. This was not a temporary malfunction. It was a complete communication failure. The rover stopped responding to commands, transmitting only fragmented and corrupted data. At the Jet Propulsion Laboratory in Pasadena, engineers worked around the clock trying to diagnose the problem. What they found was alarming. Spirit's flash memory, the onboard storage system that retained information even after power loss, had filled with so many files that the rover became trapped in a continuous reboot loop. Every time Spirit attempted to start up, it immediately crashed and restarted again. Fixing the problem required sending a software patch across 142 million kilometers of space and essentially formatting a critical hardware system on a robot nobody could physically touch. It took 2 weeks, and it worked. Only 6 weeks into the mission, Spirit had already proven something important. It could be saved. And perhaps more importantly, the people operating it were not willing to give up easily. Once communications were restored, Spirit began its real work, and Mars slowly started revealing itself. The floor of Gusev Crater turned out to be covered largely in volcanic rock. Water may once have filled the basin, but billions of years of geological activity had buried most sedimentary evidence beneath lava flows. It was frustrating. Spirit had landed in what scientists believed was an ancient lakebed, yet the surface told a different story, so the team looked farther away. About 3 kilometers east of the crater floor rose a series of low hills known as the Columbia Hills, named in honor of the Space Shuttle Columbia and its crew, lost 1 year before Spirit launched. The hills had never been part of the original mission plan. They were too far away, beyond the realistic driving range Spirit was ever expected to reach. But because the rover was performing far beyond expectations, NASA decided to try. What followed was a 3-kilometer journey across terrain filled with rocks, dunes, and loose soil, a drive that lasted months and pushed both the rover and its operators to their limits. But when Spirit finally began climbing the Columbia Hills on Sol 156, it found something completely different from the volcanic plains below. The rocks showed clear signs of alteration by water. The hills told a story the crater floor had hidden, minerals that form only in the presence of liquid water, textures consistent with long-term exposure to wet environments. The primary goal of the mission, finding evidence of ancient water, was already being achieved, and Spirit was still only a fraction of the way through its life. Spirit spent the next several hundred sols methodically exploring the Columbia Hills. Every stop produced new data. Every rock analysis added another piece to the geological history of Mars. There was Wishstone, a fine-grained volcanic rock showing signs of chemical weathering. There was Watchtower, a layered outcrop rich with clues about ancient volcanic and hydrothermal activity. And then there was Paso Robles, perhaps the most striking discovery of that entire period. A patch of soil accidentally uncovered when Spirit's wheels dug into the ground during a routine maneuver revealed extraordinarily high concentrations of salt and phosphorus. The discovery was completely accidental. Spirit had simply been repositioning itself, and in doing so, exposed material that otherwise would have remained buried forever. The salt concentrations were remarkable, levels suggesting large amounts of liquid water once flowed through the region, depositing minerals as the water evaporated or froze. It was a reminder that some of the most important discoveries in science happen not because researchers look in the right place, but because they accidentally look in the wrong one. Meanwhile, Spirit continued climbing Husband Hill, the tallest peak in the Columbia Hills, rising roughly 100 meters above the crater floor, became the rover's next major objective. The climb was slow and energy-intensive. Dust in the Martian atmosphere thickened during this period, reducing the amount of sunlight reaching Spirit's solar panels and threatening to drop power levels below the minimum required for safe operations. Then, on Sol 421, something extraordinary happened. A Martian dust devil passed directly over the rover. These atmospheric vortices are common on Mars, spinning columns of air that can reach hundreds of meters in height and clean surfaces as they move across them. And that is exactly what happened. Within minutes, a year's worth of dust was lifted from Spirit's solar panels, and the rover's power generation jumped from around 60% of its original capacity back to more than 90%. Nobody at JPL planned it. The planet itself, in a small way, had extended Spirit's life. On Sol 581, Spirit reached the summit of Husband Hill. It stopped there and did what any explorer would do after an exhausting climb. It looked around. The panoramic image Spirit captured from the summit remains one of the most striking photographs ever taken on another planet. Hundreds of frames stitched together into a sweeping view, stretching to the Martian horizon in every direction. The Columbia Hills, the flat plains of Gusev Crater below, the distant ridgelines of McCool Hill and Ramon Hill catching rare Martian light, and in the foreground, Spirit's own deck, clean and free of dust, proof that those life-saving dust devils had really happened. From the summit, Spirit also photographed both Martian moons, Phobos and Deimos, crossing the night sky in long imaging sequences designed to improve measurements of their orbital paths. Even while resting, the rover was still working. The descent from Husband Hill proved just as productive. On Sol 690, Spirit's instruments analyzed a rock named Comanche and found something extraordinary. Roughly 1/4 of the rock consisted of magnesium and iron carbonates, concentrations around 10 times higher than anything previously measured on Mars. Carbonates are minerals that form in the presence of liquid water, but are destroyed by acidic conditions. Their presence in such high concentrations suggested that at some point in Mars's history, bodies of water existed that were neutral or even slightly alkaline, conditions far more favorable for microbial life than the acidic environment suggested by other Martian geological records. It was a major recalibration of the picture scientists had been building. Mars had not always been hostile in the same way. It had been hostile in different ways at different times, and during some of those periods, something may have had a chance. At the base of the Columbia Hills, Spirit reached one of the most geologically interesting structures of its entire mission, Home Plate, a raised, roughly circular formation of layered and eroded rock about 90 meters wide. The origin of the structure was debated, but the layering patterns and rock chemistry pointed toward explosive volcanic activity, perhaps an ancient eruption that blasted superheated material across a wet surface, baking mud and sediment into layered formations that Spirit could now study up close. The edges of home plate showed features difficult to explain without flowing water or steam, sculpted surfaces, unusual mineral distributions, the kinds of things that make geologists reach for notebooks. But March 2006 brought the event that changed everything. One of Spirit's 6 wheels completely failed. The right front wheel had shown signs of increasing friction for months. Now it stopped turning entirely. Engineers at JPL performed extensive simulations on identical hardware back on Earth, trying every possible solution to restore functionality. Nothing worked. Spirit would spend the rest of its life dragging that wheel behind it, a locked metal disc, carving a continuous trench through Martian soil. And that trench changed history. In March 2007, while Spirit navigated around the western edge of home plate, the dragging wheel cut through the rust-colored surface layer and exposed something surprisingly bright beneath it, almost white, completely unlike the surrounding terrain. It was silica, nearly pure silica, concentrated at levels consistent with only 2 known geological processes: hydrothermal hot springs, where water dissolves silica in one location and deposits it elsewhere as it cools, or fumaroles, where steam and volcanic gases move through rock, stripping away other minerals and leaving silica behind. Both environments on Earth are places where life thrives. This discovery, made entirely because a wheel failed, because the rover kept driving anyway, because the dragging mechanism happened to cut through exactly the right patch of ground, was described by scientists as the single most important finding of Spirit's entire mission. If Spirit had remained fully functional, it would have driven directly over that location without disturbing it. The broken wheel was not a limitation. It became an instrument. The months that followed were quieter, but not meaningless. Spirit continued circling home plate, documenting its geology, collecting atmospheric data, and transmitting images that scientists would spend years analyzing. In June 2007, another dust-cleaning event restored Spirit's power generation to more than 600 watt-hours. The machine was still alive, but the Martian environment is patient in ways machines are not. By 2009, 2 of Spirit's 6 wheels no longer functioned. Dust storms returned, coating the solar panels and drastically reducing available power. Memory anomalies began appearing, signs of aging components under constant stress. The rover's power generation hovered dangerously close to the minimum required to keep internal heaters operating. Without heat, electronic systems would fail. On Sol 1892, Spirit drove into a patch of soil it could not escape from. The location was named Troy. Beneath the deceptively solid rust-colored crust lay a deep layer of extremely fine, loose material called jarosite, an iron sulfate with almost no cohesion. Spirit's wheels spun in place without gaining traction. Every attempt to move only buried the rover deeper. For months, engineers on Earth built a replica of the trap at JPL's testing facility and tried combinations of wheel motions, driving angles, and extraction sequences. None of them freed Spirit. On Sol 2155, NASA officially reclassified Spirit as a stationary science platform. It was not the end. Not yet. From its fixed position in Troy, Spirit continued studying the Martian atmosphere, examined the soil beneath its body, and built a long-term weather record only a stationary instrument could provide. Its robotic arm still worked. Its cameras still operated. It was no longer going anywhere. But it had not stopped doing science. The final winter arrived during the southern Martian autumn of 2010. Temperatures dropped. Power generation declined. On Sol 2196, Spirit's available energy fell back to the critical threshold of 150 watt-hours, the minimum required to maintain survival heaters. Communication attempts became less frequent. The rover needed every remaining watt simply to survive the night. Sometime around Sol 2210, Spirit experienced a low-power fault. The final confirmed communication from the rover was received on March 22, 2010. Then came silence. Spirit traveled 7.73 kilometers across the surface of Mars. It operated for 2,208 Martian sols, more than 23 times longer than originally planned. It transmitted more than 128,000 images. It found evidence of ancient water, ancient volcanic activity, and ancient hydrothermal environments that on Earth would be considered ideal habitats for life. It found all of this because it kept going long after anyone expected it to stop, because the people guiding it refused to give up, because a broken wheel became a gift.